Okay, this video is going to quickly cover the stuff that we talked about in section 5.1 for those of you that are not able to be with us in class. So 5.1 is the polygon sum conjecture. And so this is going to build off of what we already know with our triangle sum conjecture. We know that the three angles of a triangle have to add up to 180 degrees. But the question is then, what about other shapes? Is there a rule? Is it always the same? What's going on there? And so that's what we're going to look at. We're going to look at a pattern for the sum of the angle measures for any polygon. Now, really quickly, we talked about this in class, so I'm going to make sure I review it here. A convex polygon is going to be a polygon that always has its vertices pointing out. So there's a convex polygon, and in contrast here, a concave polygon is one where at least one of the vertices points in. So you might have something like that going on. Now, technically, the thing that you're going to learn in this video works for both of them, but if you wanted to work along with me here, a convex polygon is going to be the one you want to use just because it's easier to deal with. You don't have to worry about what to do with this angle, which is actually bigger than 180 degrees. So here's what we did in class. Whoa, just made my video very large. Okay, so in class, we worked on an activity here, a little investigation where we looked at the different numbers of degrees for different polygons. And so we know a triangle with three sides has 180 degrees. And then we went and we looked at quadrilaterals and pentagons. And so let's go ahead and let's take a look here. If I went and just measured some of these, I'll do it as quickly as I can here. So that one looks like it's right at 65 degrees. So I'll see if I can type in there. So 65 degrees right there. Move over to this one. That one's over here, way past 90 degrees, almost 100. We'll go 99 degrees on that one. We'll flip this around and start measuring these up here. Remember, when you're using a protractor, the little vertex indicator has to go on the vertex. You line up the 0 right there on one side, and then whichever axis or whatever scale has the 0 on it, that's where you're reading. So I'm reading off the inside scale here. There's 80 degrees on that one. And up here, where 0 is on the outside scale, so I'm reading over here, we're looking like maybe 116 degrees. So something like that. What we did is we all did this together as a class. Each person did their own shape, so they were all slightly different, and then we added them up. So 116 plus 80 plus 65 plus 99, and I happen to get exactly 360. Now, most of the time, I don't end up exactly at 360 because we're talking about some error in there. But once we get a whole classroom of people together, some are bigger than 360, some are less than 360, but it's pretty clear that we are looking for a number that is pretty close to 360. And so four-sided shapes always have 360 degrees as the sum of their interior angles. Just talking about these four interior angles. Then we went down and we looked at the same thing for a pentagon. So we measure these angles, and this would be a good thing, if you want to do this one along with me and measure on your own. So there we've got 70 degrees. There on the inside scale, looks like 110. Up here, rotate it around a little bit. So there we look like we're at about 120. And so what you hopefully are starting to notice here is not only are there more angles in a pentagon, but that the angles tend to be bigger as well. In order to get more sides, they all have to open up further. And so here we've got one that's 155. And our last one here, doing pretty good at getting these at least to nice multiples of 5, except for that one. That one looks to be, we're on the outside scale here, so 87 or so. So I'll bring back the calculator here. So we've got 87, 155, 120, 70, and 110. Now I got 542, which is not exactly what it's supposed to be, but when we do this all in class, we see some people end up a little less than 540, some people end up a little bit bigger than 540, but overall, we're looking for 540 as what that should end up being. So here we've got in the 5 category here, 540 degrees. Now it's at this point that I start asking the question, should we do another one? Or do you think we have enough of a pattern that we can keep going without having to keep measuring these? And so hopefully you've realized that each time we are adding 180 degrees. Each time we add a new side to a shape, the total angle measure inside gets 180 degrees bigger. So 180 plus 180 is 360. 360 plus 180 is 540. 540 plus 180 is going to be 720. Shrink those down a little bit. Try to get it so I can write in these. So 720. If I add 180 again, I get 900. If I add 180 again, I get 1080, and so on and so forth. Now, that would work well and good if we just needed a few. You could probably remember the first 2 or 3. You could just add 180 to get to the next 4. And 1 through 8, not so bad. You get there. But what's going to end up happening here is we're not just going to talk about shapes up to octagons. We're going to talk about shapes that have lots of different numbers of sides. So if you had a shape with 15 sides or 18 sides, you don't want to just keep adding 180 over and over and over again. That gets a little annoying. So we want to come up with some sort of a rule on this. And hopefully something that you remember from algebra last year is anytime you see a rule where you are adding the same thing over and over and over again, that is going to be a linear function. It's going to be a multiple of the variable, something times this number. Now it might have a plus something or a minus something at the end if you remember your equations from last year in lines. So we got to figure out what that is. And to do that, what we're going to be looking at is looking for patterns. So we're going to all tie this thing back to triangles. So we know that a triangle is 180 degrees, and we actually did this where we took the 2 angles, put them together, and showed that it made a straight line. So we've done that already. Now take a look at what happens with quadrilaterals. We know the total here is 360, but the idea here is we actually want to split this thing up and make it into something we know. We know triangles. So if I take this quadrilateral and take those angles and split up, see it's got a triangle in it and another triangle. So we've got 2 triangles, 180 degrees in each, 360 degrees. For a pentagon, we're splitting it up into 3 triangles. Notice how we're only concerned about the interior angles. So we're not like trying to split up into as many triangles as possible. We're trying to split it up so that there's no intersections between the triangles. So a pentagon got split up into 3 triangles. 3 triangles was times 180, 540. A hexagon, just the same way, is going to be split up into 1, 2, 3, and 4 triangles. 4 times 180 degrees gives us our 720. A heptagon, 7-sided shape, is going to go 5 triangles. So 1, 2, 3, 4, and 5. And so hopefully you're noticing a pattern here. However many sides there are in the shape, we're splitting it up into 2 less triangles. So a 7-sided shape has 5 triangles. Each of those 5 triangles is 180 degrees. There you go. And finally here we've got an octagon. Octagon, guess how many triangles here? 2 less, so it's 6. So 6 triangles times 180 degrees each gives us our 1080. So we're back here talking about that. If you noticed, we've just gone through and kind of done these. A 5-sided shape was split up into 3 triangles. A 6-sided shape got split into 4. A 7-sided shape got split into 5. An 8-sided shape got split into 6. And which means in general, if we're writing an equation for this, we just take away 2 from the number of sides. An n-sided shape is going to be n minus 2 triangles. So if I have a 17-sided shape, there's going to be 15 triangles in it every single time. From there, all we do to find the angle sum is just multiply by 180. So we take 3 times 180, whatever that is. I'm actually going to write it out because it's helpful to have it written out. We're just taking that number of triangles times 180. So 4 times 180, 5 times 180, 6 times 180. And keep in mind, these numbers that I'm multiplying by 180 are not the number of sides, they're the number of triangles in there. That's how we figuring this out. So if I went up to this one, I'm taking n minus 2, n minus 2 times 180. And that is our formula for the total number of degrees in any polygon. And that's what we ended up writing down in our conjecture list. So if you were gone yesterday, or if you were gone on the day that we did this, write this in that conjecture packet. Remember, this is very important that you're keeping these up to date because the whole thing we're learning about is these conjectures. That is geometry. So the sum of the measures of the n interior angles of an n-sided polygon, n-gon just means n-sided polygon, is 180 times n minus 2. Pause the video, write that down. That is important. Okay, so a couple of things then we're going to have to do with this are finding missing angles is kind of the biggest one. The first thing you're always going to want to do is take a look at how many sides it has and use that formula. So here we've got 5 sides, so I'm going to use my formula 180 degrees times 5 minus 2. Well, 5 minus 2 is 3, and that gives me 540 degrees. So I know the total here has to be 540. Now I can start to work out what individual angles are using things like linear pairs. If this one is 72, this one has to make 180 degrees with that. So 180 minus 72 has to be 108. So I found B right away. Well, I've got one down here that's marked as a right angle, so I know that one's 90. These two angles are marked congruent, so I know this one also has to be 120. And now I can use the fact that I know 4 of the angles and I know the total. So I can take my 540 minus 108 minus 90 minus 120 and minus 120 again. And please do not do this in your head or on paper. This is what calculators were invented for. So 540 minus 108 minus 90 minus 120 minus 120 is 102. So we know that this missing angle up here has to be 102 degrees. So that's pretty much the idea here. You're going to be combining things that you've learned before with new things to find missing angles or solve some problems.